Hello everybody and welcome back to Maths Miss Buick. We're still focusing on differential calculus and in this video we're looking at trigonometric derivatives, but in particular the derivatives of sine to the power of nx and cos to the power of nx. So let's begin the first question. We've got f of x is equal to sine to the power of 3 x squared plus 2. So we'll start off by using our notation. I always treat these questions like the chain rule because we know that powers always represent chain rules. So you bring your power in front as you would in the chain rule. You leave everything alone and you reduce your power by 1 as you would in the chain rule again and rewrite the bracket. And then in the chain rule, you would always get the derivative of what you have. So if you get the derivative of sine goes to cos. We differentiate sine x squared plus 2, you keep your x squared plus 2 and then you differentiate by the bracket. So if we differentiate x squared plus 2, we get 2x. So there we have it. We can finish off our answer by bringing our 2x all the way to the front and multiplying it by the 3. So we have 6x sine squared x squared plus 2 cos x squared plus 2. So the rule is we treat these questions like the chain rule. We begin by taking our power and putting it down to the front. We keep our sine. In this case, we're not differentiating yet because we're treating it like the chain rule. So there's our sine. In the chain rule, we bring the power down by 1, so it's now positive 2, and we keep all of the bracket. That's the first step. Next of all, we multiply by the differential of the bracket. In this case, we're differentiating the sine x squared plus 2. So we differentiate sine goes to cos, and you leave the x squared plus 2 alone as we differentiate trigonometric derivatives, and then you multiply by the differential of the bracket. In this case, bring the 2 to the front, so we get 2x, and of course, the 2 goes to 0. And then to finish it off, to tidy it up, we bring the 2x to the front with the 3 and multiply. So let's try the next example. So here we have f of x is equal to tan squared x, 4x plus 1. So let's write out our f dashed of x. Again, we're going to treat this like the chain rule. So we take our power and we put the power to the front. So there's our 2. We do not touch the tan, we leave it as it is, and of course this will go down by 1, so let's put a 1 there for argument's sake. And then we leave our 4x plus 1 alone. That's the first part. Next of all, we're going to differentiate. So we differentiate all of this part here. So tan goes to sec squared. We leave our 4x plus 1 alone, and then you differentiate by the bracket here. So 4x will go to 4, and we know every constant goes to 0. And let's finish off by bringing the 4 to the front and multiplying it by the 2. So 4 by 2 is 8. Tan 4x plus 1 by sec squared 4x plus 1. And we're done. So the rule is, again, let's go back over it. We take our power on our trigonometric function and bring it to the front. So there's our 2. We then leave everything alone. Do not touch anything, but bring your power down by 1. So there's your 1. That's the first part done. Next of all, you're going to differentiate the tan and the 4x plus 1. So we differentiate tan, it goes to sec squared. You leave your 4x plus 1 alone as you would normally in differentiating trigonometric derivatives. And then you differentiate by the bracket. So in this case, 4x goes to 4, your constant goes to 0. So bring the 4 then to the front, multiply by the 2 to give you 8, and rewrite everything as you have it.